In this problem, we've got a student travelling to school by bus 40% of the time, and the rest of the time she travels by car. We know that when she uses the bus, she's late 0.3 of the time, and when she travels by car, the probability she's late is 0.2. So the first thing is to find the probability that she's late. So according to this, we've got to think through the scenario as it's happening. She either takes the bus or she comes by car. So the probability she comes by bus is 40% or 0.4, and the rest of the time by car, making that 0.6. Now that she's chosen her method of transport, she's either late or she's not late. And we can do the same thing if she travels by car. She'll either be late or not late. Now the probability, it says that the probability that when she travels by bus that she's late is 0.3, which means that she's not late or she's on time, 0.7, and if she travels by car, the probability she's late is 0.2, so not late is 0.8. So to answer A, the probability that she's late, we need to work out this branch and then add them together. So once again, we multiply along the branch, so the probability of bus and late, or we could have written that as B intersection L, will be 0.12. So we're multiplying 0.4 times 0.3, and the probability of the car and late will also be 0.12 because we've got 0.6 times 0.2. Now we take both of those to answer A. The probability that Tracy is late is 0.12 plus 0.12 or 0.24. Okay, so that's that first part. Now the second part says given that she is late. So we've already been told she's late. And we want to find out, given that she is late, what's the probability she used the bus? So we can do this two ways. We can first of all use the formula that we now know for conditional probability. So according to that formula, we're looking here at the probability she is late given, the probability she used the bus given that she is late. So bus given that she's late. Now whatever probability is the given part, so given that she's late, goes on to the bottom line. So we need to know the probability she's late. And the top line is the intersection between these two. So that's bus and late. Okay, the probability she takes the bus and is late is 0.4 times 0.3. Bus and late. 0.4 times 0.3. And the probability that she is late is the answer that we worked out in part A, so 0.24. Okay. This 0.12 over 0.24 comes down to being 0.5. So given that we know she's late, there's a 50% chance that she actually took the bus. Now I said there were two ways of working that out, so we can look at the conditional probability formula, or we can just narrow the sample space from our tree. So we can see that she could have been late here and here. So the probability of being late is adding these two together. So this is still going to find the probability that she caught the bus, given that she's late. But our sample space has been reduced to just the late ones because we know that's what we're talking about. So just looking at the late ones means that we're out of 0.24 now. And we want the bus making her late, which is the 0.12. So we can either do it from the formula or from looking at a tree diagram, and both will give us the answer of 0.5.